Alright, we're going to talk about the composition of functions. It says if f and g are functions, then the composite function, which is f of g, or it says fog, it looks like fog, or the composition of f and g is defined by this. F of g of x means f of g of x, just like this. It means that the function g of x is the input into the function f. Okay, that's what it means. Now let's look at this one. They mean the same thing. This, and this mean exactly the same. I prefer this because literally you can see the function g going in, right? This one's kind of confusing, so I normally use this one. But in Math Excel or anything else, they mean the same. So what this says now, let's follow the input here. F of g of 5. We start in the middle. The input is 5. And look where it goes into. It goes into the function g, right? And then you get an output. So you have to evaluate g at 5 and you get some kind of output. We call that output g of 5. That output then becomes the new input for the function f. So then you take f of whatever g of 5 is, and then you get an output called f of g of 5. So it's kind of like a little snake or like a worm. You have to start with the 5. It goes into function g, and then you evaluate it. Then you get a number from that, and you put it back in replace of this, and you go into the function f, and then evaluate it. So here are two functions. I've got f and g. I've defined them now. So watch how it works. G of 5. I need to go and find out what g of 5 is. So g of 5. So I'll go up here and find out what g of 5 is. I put a 5 in for the x, which replaces that x with a 5, right? Squared. So 25 minus 2 is 23. So that's what g of 5 is. So this thing right here is going to become a 23. Look where it is. So I write 23. Alright, then now it says f of 23, right? Before it was f of g of 5, but we got that. Now f of 23, go to the function f, replace that x with a 23. 2 times 23 plus 1. That would be what, 46, 47? So that's what f of 23 is. So the function, or f of g of 5 is equal to 47, because first you evaluate g at 5, and we got 23, and then 23 goes into f and gives you 47. So f of g of 5 is 47. Alright, I would like you to try this one here. G of f of negative 2. These are the two functions, and see if you can find what g of f of negative 2 is. So pause the video and try it. Okay, so g of f of negative 2, I need to find out first what the negative f of negative 2 is. Okay, so I go over here, there's f, and I say, okay, f of negative 2 means replace the f function with a negative 2. 2 times negative 2 plus 1. That's negative 4, that's a negative 3. So now this is g of negative 3, because this equals negative 2. Or sorry, this equals negative 3. Now g of negative 3, well there's negative 3, right? Take g of negative 3, put it in here. Negative 3 squared. See how I'm always putting things in parentheses when we replace an x? You need to replace it so you square it appropriately, right? So negative 3 squared is actually positive 9. 7. Alright? So that means that this is equal to 7. So that means that g of f of negative 2 is equal to 7. Alright, in this example we're going to evaluate a composition symbolically, so without the numbers. So first we should state the domain of each of these. Okay, this is a parabola, right? So f, the domain of that would be all real numbers. And g of x, the domain of g would be what? Well, you can't have numbers, you need x minus 1 to be greater than or equal to 0, right? So we need x greater than or equal to 1. Okay? Because remember, just like adding, subtracting, multiplying, dividing, composition of functions, the domain could be restricted by one of these. Okay? So f of g of x. So we're supposed to put the function g of x inside f. And the function g of x is this. So we're actually going to replace this portion right here with that whole function. So f of square root of x minus 1. So that means put the square root of x minus 1 in place of each x that you see here. So, and that means you're supposed to square your inputs. So this whole thing is replacing this x, and it gets squared. So then I square a square root, I just get x minus 1. So f of g of x is equal to x minus 1. That's what the function of the composition of functions is equal to. Now if you look at this, you would think that the all real numbers would be the domain, because x minus 1, you can put any number and subtract whatever you want. But remember, you must follow the little wormhole. The numbers actually go into x here, right, which is actually into g. So you are restricted by what numbers you can put in here. So x equals -3 works here. -3 minus 1 is -4, right? But -3 does not work here. See? It doesn't work here. Square root of -4, not real, right? So we have to restrict our domain of the g function. So the restriction of the domain is for all x greater than or equal to 1. Okay? Alright, let's find g of f of x now. Okay, so we have the same functions, but we're just going to find the opposite way, right? G of f of x. We're going to take the function f of x and put it into the function g. Okay, so that means this will go inside right there. So we have g of f of x will be equal to g of x squared, right? Because the function f of x is x squared. Alright, and then I'm going to take function g and put an x squared in for the x. So replace this guy with an x squared. There we go. Alright, and that's it. G of f of x is equal to the square root of x squared minus 1. And you can't simplify that. I can't take the square root of that. It doesn't work that way. That's it. But what's the domain? Well, I can put any number I want into x, right? Because it will square and be positive. But then when I subtract, I got to be careful that it doesn't become a negative number. So remember, this is a little tricky. When you're trying to make x squared minus 1 greater than or equal to 0, that's one of those problems with a quadratic inequality. Okay? So we'll try to think of the graph of this, which is a parabola that's been shifted down 1 unit. And I think about these as being the y values of that parabola. X squared minus 1 is the whole function output, right? So when are the y values greater than or equal to 0? Well, we got to find when they're equal to 0 first, right? So I do this, I add 1 to both sides, square root both sides, and we find that x are equal to 1 at or equal to 0 at -1 and +1. But then if you choose values up here for the y values, right? They're all positives. These are all positives, so the x values over here and over here will produce positive y's. Meaning, if you choose a value here, it'll produce an output that's positive, like 2 is over here, right? Watch, if I put 2 in there, 2 squared is 4, minus 1 is 3, and 3 is greater than or equal to 0. But if I choose a value here, like 0, 0 squared is 0 minus 1, I get -1, and that's not greater than or equal to 0. So, for my domain of my composition of functions, I want to choose x values that are less than or equal to the -1 and greater than or equal to +1. So the domain would actually be from -infinity to -1, including union with 1 to infinity. And that's the domain of this guy right here. This keeps this always positive, because if you choose numbers between -1 and 1, you're going to be subtracting 1 from it, which will be negative. So this was a little tricky to find the domain here. You had to use some other knowledge, but that's the composition of functions with the domain.